So I have dealt with that means scalar, super pipeline, under pipeline, super pipeline also. So these are all under instruction pipeline. There are two classification schemes of pipelining. One is given by the scientist Handler, and another one is given by Ramurthy and Lee. And according to level of processing, Handler has classified into arithmetic pipeline, instruction pipeline, and processor pipeline. Three types of pipelines are there: arithmetic, instruction, and processor pipeline according to Handler. And according to Ramurthy, unifunctional or multifunctional, static or dynamic, and scalar or vector. So anyway, in arithmetic pipeline, ALU is divided into stages. In instruction pipeline, instruction is divided into stages. Processor pipeline, same data stream passes through various processors. Stages of processors are there. So in instruction pipelining, you can see that scalar, superscalar, under pipeline, super superscalar, super pipeline come. And this static or scalar or unifunctional, in fact all are same. I will show you afterwards. Static, unifunctional, both are same. And single reservation table will be there. We will see afterwards what is reservation table. So dynamic pipeline gives multifunctional pipeline, or it has more than one reservation table. We will see that. So arithmetic pipeline. So ALUs are segmented, and example is in Cray 1. 14 stage pipeline is there. That means ALU is divided into various stages, arithmetic logic unit. So this is called arithmetic pipeline. Arithmetic example is this also means instruction pipeline, in which instructions are coming from different programs. Different programs are giving. We will see here there are various instructions. This is one instruction, this is second, third, fourth, fifth. But these instructions are coming from here. So may be coming from different programs. Okay, may be coming from different programs. These instructions, this may belong to one program, this may belong to some other program. So the same thing is shown, that instruction 1, these are the instructions. Instruction 1 is coming from second program module. Instruction 2 is coming from third program. Instruction 3 is coming from first program. Not necessarily that first program will give first instruction, it is not like that. Third instruction is giving third program is giving first instruction like this. So first instruction is coming from second program module. First instruction is coming from second program module. Second instruction is coming from third program module. So this is instruction pipelining. Then is processor pipelining, in which processor pipelining refers to processing of same data stream by cascade of processor. As I told, there are stages of processor, and one is that means this processor is taking data from this memory M1 and is writing its result into memory M2, and some task is performed on processor 1. Task 2 is performed on processor 2, and task 3 on processor 3. Data is taken from one memory and is written into other. This is processor pipeline. So anyway, we have seen the classification of pipelining according to the two scientists. But here we are simplifying, trying to simplify pipelining as static pipeline and dynamic pipeline. This static may also be called as linear or unifunctional. Dynamic may be called as non-linear or multifunctional. which you had seen in Ramurthy and Lee classification also. So that means static pipeline will give only one function as output, but dynamic pipeline is multifunctional. That means multiple functions can be performed. So we will see how. This is suppose one pipeline, S1, S2, S3 are the stages of those pipelines. As I told, that pipeline is always performed in stages. All the practical examples I had given, PET counseling or anything, there are stages. So suppose these are the stages, S1, 2 and 3. And some input is coming and some output is going. This is called static pipeline or linear. This is also called linear pipeline, and this is also called unifunctional pipeline. Only one type of operation can be performed. But dynamic reconfiguration takes place for different functions, and there will be feedback and feed forward channels. In dynamic pipeline, what happens that multiple functions can be performed, and there are feedback and feed forward channels. So a dynamic pipeline with two different functions. Now we are seeing dynamic pipeline in which two functions can be performed, not one. Two functions can be performed, and these functions are output X and output Y, and these are the three stages. And as I told previously, that there are feedback and feed forward channels in dynamic pipeline. So you can see that this is a feedback channel from S3 to S2, and this is called S1 to S3 directly. This is a feed forward. This is a feed forward channel. So input and S1, S2, S3, etc. output Y, and there is one like this feedback, another feedback, and this is a feed forward channel. So the occupancy of stages in a pipeline is shown by a table which is called reservation table. That means which stage is occupied by which task at which time. There are various stages in a pipeline, and when pipeline comes into full load, then various instructions are being executed, thousands of instructions. So you need to identify the instruction. So which instruction is executing in which stage at which time, that is shown by reservation table. So this is how it is shown. These are the cycles and stages, and this is for function X, output X. So that means you see here that input is coming from going into S1, then into S2, then into S3. Then it is going into S2. Here also it is S1, S2, S3, S2. That means S1, S2, S3, then it is coming back into S2. And then again it is going to S3, like this. From S3 it is coming to S1. See, from S3 it is going to S1. S3 it is going to S1. And then from S1 it is going directly to S3. S1 it is going directly to S3 like this. And then from S3 again it is coming to S1. Again it is coming to S1 and then output. That means S1, S2, S3 like this. Output is coming in 8 cycles. This is clear? Reservation table. So this same combination of stages with the help of feedback and forward, different functions can be obtained. Like here, as I told, from S1 it is going to S2, then S3, then again to S2. That means S1, S2, S3, and from S3 to this feedback S2. S3 to S2, like this. And S2 to S3 again, S2 to S3. And from S3 again into S1, S3 again into S1. And then from S1 again into S3, S1 into S3. And then from S3 into S1, from S3 into S1 and then out. This is function X. Similarly, function Y is like this. In S1, then directly to S2 in second cycle. In second cycle, it is going into S3. So S1 to S3 it is going, and from S3 it is going to S2. So S2 like this, S2, and then from S2 it is going to S3, and from S3 it is going to S1, S3 it is going to S1, and then from S1 it is going to S3, S1 it is going to S3, and then it is going out, output Y in 6 cycles. So this is the reservation table for output Y, this is the reservation table for output X. Two types of outputs are being taken from this same pipeline, and this is called dynamic pipeline or multifunctional pipeline, also called non-linear pipeline. Because non-linear, why? Because S1, then S2, then S3, then S1, then S2, any type of, not necessarily that S1, S2, S3. This is clear? Dynamic pipeline, this is called dynamic pipeline or multifunctional pipeline or non-linear pipeline. So, I had shown you the normal static pipeline, and this is dynamic pipeline performing two different functions. More functions can also be performed. This is clear, dynamic pipeline. And the subject you are studying parallel computing in 8th semester or not, in any semester, advanced computer architecture or parallel computing. So I think you might have studied also to some extent. So collision-free scheduling in dynamic pipeline. In dynamic pipeline, it is necessary that collision should not occur. Collision must not occur for finding out correct result. And how to ensure collision-free scheduling in dynamic pipeline? So Davidson and his students gave in the year 1971 to ascertain that at a certain method they have given. So in that method, we find out forbidden latencies. And how to find out forbidden latencies for output X and output Y. That means forbidden latencies means latencies which are forbidden, not permitted. Then other latencies which are permitted. How much latency should be given or not. That is defined already with the help of this method. So for output X and output Y, like this. See, in this reservation table, suppose S1 is occupied in first clock cycle, then in 6th clock cycle, then in 8th clock cycle. Suppose there is a delay which is given in S1 stage of 1 cycle, that means another function is occupying this stage, then is there some problem? No. Because the stage 1 is free during these 2, 3, 4, 5 cycles. But it is not free in 6. So we should not give a delay which gives some initiation at 6 or 8. That means forbidden latency is 6 minus 1, 5. That means you can start any other function at second stage. That means you can utilize this stage for some more function here, some more function here, but not here, because the stage is already booked by function X. So this you have to keep in mind while executing pipeline operations. Otherwise collision will take place and one stage cannot perform 2 operations simultaneously in one cycle. So that is why the concept of forbidden latency is there. And for output X, these are the forbidden latencies. That means 8 minus 1, 6 minus 1. From where it is taken? See, 8 minus 1, this is forbidden latency. 6 minus 1, this is also forbidden latency. 4 minus 2, this is forbidden latency. 5 minus 3 is also forbidden latency. This 7 minus 5 is also a forbidden latency. And 7 minus 3 is also a forbidden latency. That means you should not give these delays. And therefore forbidden set of latencies is like this. 2, 4, 5, 7. This is called forbidden set of latencies. And for function y, these are the forbidden latencies and forbidden set of latencies. That means if these cycles, during these 1 and 5 cycles, stage 1 is not free. You have to keep in mind. And you can make use of second, during second, third and fourth cycle, this is stage 1. You have to utilize stage 1 by some other function, then you should utilize when either during second clock cycle, third or fourth or sixth, but not in 1 and 5. Clear or not? आपका जो पाइपलाइन का नॉर्मल एग्जांपल ये पीटी काउंसलिंग वाला, उसमें कोई पर्सन रजिस्ट्रेशन काउंटर पे बैठे हैं, तो अब मान लीजिए कोई स्टूडेंट नहीं है कुछ समय, तो तब तो ठीक है, लेकिन अगर वो बुक्ड है तो एक और को तो नहीं कर सकते, तो आपको यही पता करना है कब वो बुक है कब नहीं. दैट इज फाउंड आउट विद द हेल्प ऑफ दिस रिजर्वेशन टेबल. दैट मीन्स ईच स्टेज इज बुक्ड एंड व्हेन इट इज फ्री. That is shown by reservation table, and accordingly you have to start performing new operation. So in stage 1 for output y, you can not use during first clock cycle, but second, third, fourth it is free. Forbidden latencies are 5 minus 4, then 4 minus 2, 6 minus 4, 6 minus 2, etc. So that is shown here. Output y like this, and therefore forbidden set of latencies are kept by 2, 4. These are called under Davidson method, and these are taught and asked also in the final year, fourth year, etc. in the subject of parallel computing. So then collision vector is known, and collision vector is like this C1 to up to n. Collision vector is a binary vector, 0 or 1, in which Ci is equal to 1 if I belongs to F, if I belongs to F, and n is the largest forbidden latency obtained from the reservation table. Therefore, n is equal to 7 for x and n is equal to 4 for y, and Cx is like this. Cx is, that is for function x, collision vector is this, for function y, collision vector is y. 1, 0, 1, 0. How? See, 2, 4, 5, 7 is the forbidden set of latencies, and from this forbidden set of latency we find collision vector by that formula which I have given. How? 2, 4, 5, 7. You remember this 2, 4, 5, 7, and we will find out collision vector. This is for x. 1 is present. Yes or no? No. So it is 0. In forbidden set of latencies, it was 2, 4, 5, 7. So forbidden latency is 1 or not? No. So it is 0. Forbidden latency is 1. Yes. 1, 2, it is okay there. So it is 1. Then 3 is not there, 0. 4 and 5 are there, 1, 1. 6 is not there, 0. 7 is there, then again it is 1. To correlate both. Forbidden set of latencies for x is 2, 4, 5, 7. So 2, 4, 5, 7. 1 is present or not, like this. 1 is not present, so it is 0. 2 is present, so it is 1. 3 is not present, 0. 4 and 5 are present, 1, 1. 6 is not present, it is 0. 7 is present, so it is 1. So this is how this collision vector is obtained. Clear? Collision vector. And similarly for y also, Cy. 2 and 4 are the forbidden set of latencies. Forbidden set of latencies is 2 and 4. So 1 is present, no, 0. 2 is present, yes, 1. 3 is present, no, 0. And 4 is present, yes, 1. So 1, 0, 1, 0 is the collision vector. After that, we draw a state transition diagram and then find simple cycle, greedy cycle, ML, minimum average latency. So I am not covering that part here, but this brief detail I have given. If you want to go more in detail, you can go through the book of Kaiwan, Fritz, etc. Any doubt in this? I have told you about forbidden set of tendency and collision vector. Why it is important? In pipelining, you have to perform various functions, but at the same time, you have to keep in mind that there must not be any collisions. Collision-free scheduling you have to do. For that, this is necessary. Now come